This is presentation about information criteria for model selection. So, what are information criteria? These are measures of the relative quality of a statistical model for a given set of data. That is, given a collection of models for the data, they estimate the quality of each model relative to each of the other models. So, when you are developing your econometric analysis on some data, you will try to experiment with different variables in your model, different transformations. You will exclude some variables, you will include some new ones. You will try to implement maybe logs or squares of your variables, etc. And at the end, you need to compare these models and to choose which of these models is the best one. There are 4 information criteria usually in real life in practice that are used, and these 4 criteria are also the output of every model that you do in Gretel. So we have AKAI criterion, Schwartz criterion, AKAI criterion, and log likelihood. So the first one, AKAI, is one of the best known. It rewards the goodness of fit, assessed by the likelihood function. It is very good for linear models mostly, but it also includes a penalty that is an increasing function of the number of estimated parameters. So it will punish you if you add too much variables in your model. So the penalty discourages overfitting. Increasing the number of parameters in the model almost always improves the goodness of fit. But you must be aware that AKAI does not provide a test of a model in the sense of testing a null hypothesis. AKAI can tell you nothing about the quality of your model, so it is up to you. It can only compare different models, but it cannot say if all your models are bad, then if you choose the one with the lowest AKAI value, it doesn't mean that you have done the best modeling. So AKAI will not give you any warning about the quality of your model, and you must be aware of it. So the smaller the better. If you compare some models, the smaller AKAI is, the better is the model. Second criterion is Schwartz criterion, BIC usually is called. So it is also based in part on the likelihood function, and it is closely related to the AKAI information criteria. But it also can punish you for overfitting, but it is even more stricter in comparison with the AKAI. The penalty term is larger in big model than in AKAI model. Again, also the smaller the better. When it comes to Hannah Quinn, it is not so popular criterion, but it is also the output of the Gretel. It is very similar to Schwartz-Big criterion. Asymptotically, it is equal, so if n grows to infinity, it is almost the same as BIC criterion. Again, smaller the better. The fourth one is very good if you have, for example, binary dependent variable. So log likelihood is actually the value of the likelihood function with obtained coefficients. It is based on the summing of the probabilities associated with the predicted and actual outcomes, and it is analogous to residual sum of squares in multiple regression. The higher the better. So in comparison with other criterion that we already mentioned, when you are using the log likelihood, it is better if it is higher. When you're choosing which of these criteria to use on your data, so probably when it comes to linear data, linear modeling, it is better to use the AKAI and BIC models. BIC is stricter, but when it comes to binary dependent variable, probably you should use first place log likelihood criterion. So here is one example. I've done 4 models, 1, 2, 3, and 4, on our data with the test score as dependent variable, and I've changed the list of independent variables. So in the first case, we have student-teacher ratio and average income for every district. In the second model, I've added the square average income because we have discovered a nonlinear relationship regarding the average income and test scores. In the third model, I've added percentage of English learners, and in the fourth model, I have excluded student-teacher ratio. So if you compare, for example, all these criteria, let's look at this Schwartz criteria. So it is lower and lower if you go from model 1 to model 2 to model 3 to model 4. But in the fourth case, the model is just poorly improved, just for some 6 points. So, and also is valid for all other criteria that you see here, like AKAI, HANA Queen, and log likelihood. So log likelihood actually goes up as the model is better. So in this case, in comparison of these four models, the model number 4 is the best model according to information criteria. But again, you must be aware it doesn't say anything about the quality of your model. You still need to check for heteroscedasticity, multicollinearity. We actually exclude the student-teacher ratio, although we know that it is actually correlated also with percentage of English learners and the test scores. And also you need to check for normality of your residuals. So there is also still a lot of work in order to check the quality of every model. Actually, first you need to check the quality of your models, checking the heteroscedasticity, multicollinearity, normality of residuals, and then among those models that have satisfied the assumptions of the modeling, then you can compare them and choose which of these models has the lowest criteria when it comes to Schwartz, AKAI, or HANA Queen, or highest when it comes to log likelihood. Okay, this is the end of the presentation.